Welcome to Stemble Simulations. My name is Jason, and I'll be giving you a brief tour today to help you get the most out of this technology. First, I always like to experience these labs in full screen mode, so I'm going to go ahead and click that button on the top right. Now, your instructions will show up here on the left, and they'll live update as you proceed through the required steps of the lab. By scrolling or zooming in on a touchscreen device, you can also get an up-close look at the lab bench and the objects on it. If you'd like to get an even closer look, double-clicking on any item will zoom you into that item. To zoom back out again, you just need to click or tap the zoom out button at the top of the screen or hit the enter key if you have a keyboard. Objects in the virtual lab are selected by clicking or tapping on them, and they can be moved to locations that are indicated with an orange silhouette. So this water bottle, for example, once selected, I can move it to this position where I can use it to add water to this graduated cylinder. Now that happens to be the first instruction on the left, so I'm going to go ahead and use my arrow keys as it indicates down here on the bottom to increment the volume of that water that I'm putting into this grad cylinder. The instructions say to put between 10 and 15 milliliters in the cylinder, so once that's completed, you'll notice that the step gets a check mark and you can move on to the next step. Now in this lab simulation, we're going to be measuring the densities of both a solid and a liquid sample. Now density is defined as the amount of mass per unit volume. So determining the density of a substance in the lab requires a measurement of both the mass of the substance and its volume. So let's start with a solid sample. Now to measure the volume of a piece of unknown metal, we're going to submerge it in that graduated cylinder of water. By observing the change in the volume within that graduated cylinder, we'll be able to determine the volume of the metal that was added. First, we're going to determine its mass. This object's called a weighboat, and we're going to move it over to the balance. Now we can take a note of that mass of the weighboat, or we can push the 0 button over here, which is called taring the weight of that weighboat. What we can do now is grab our piece of unknown metal and put it onto the weighboat. So let's bring the weighboat back out to the bench top, click our unknown metal, and dispense it onto the weighboat. Now what we'd like to do is weigh this, the combined piece of metal and weighboat, so that we get a mass of the unknown metal. You're going to want to jot this down because it's going to be useful with your density calculations. Now what we're going to do is move this metal over to the graduated cylinder, and we can make a note of what volume this graduated cylinder is now at. And taking the first volume that we made note of in terms of where we filled it, and now the second volume, we can get the volume of that piece of metal. And again, mass per unit volume will give us the density of this metal. Now, to determine the density of a liquid, let's first measure the mass of this graduated cylinder. And again, we'll tare it just to make sure the mass of the graduated cylinder doesn't influence the mass of the object we put inside. So let's put it back to the bench top, and continuing to follow our instructions, we're going to take an unknown liquid. We're going to measure some of this unknown liquid into a beaker. And that's generally true in labs. We want to dispense our samples from a beaker, not from the original bottle that they've come in. So now what we're going to do is we're going to pour, as it says, between 5 and 10 milliliters of this sample into the second graduated cylinder. Again, using arrow keys, I'll fill up the cylinder to a particular volume and take note of what that volume is. Now what we're going to do is move this graduated cylinder back to the balance so that we can see what mass of liquid that particular substance is. So we've got a mass measurement and we've got a volume measurement. But with a liquid, we can actually go a few steps further and repeat this measurement to get a number of different data points. Let's go back to our beaker and put more liquid into the graduated cylinder to take successive measurements of different volumes of this liquid and their associated masses. In all, this experiment calls for 3 total measurements like this. So after the second measurement, we'll put the grad cylinder back on the bench top, get some more of our liquid, add another 5 to 10 mils to this graduated cylinder, and once that's complete, we can take a final mass measurement, and that will give us 3 individual data points that all give us a mass and associated volume for this particular unknown liquid sample. That should be plenty to determine a density, and now you know the density of both your unknown metal and the density of an unknown liquid. That density is often quite diagnostic, and it will let you determine what those species actually were. When you're finished the lab, you'll notice you have a little thank you message printed out down to the bottom, and when you come back out by pressing the full screen button again, you'll notice that you've been given full credit for doing this assignment. I hope it's been helpful for you, and let us know if you have any questions.